You might have noticed that the grains are clicking at the moment. If I, at the beginnings and the ends of the grain, there will be a click, and you can hear it particularly if I drag between. You can hear it clicking at the moment, and that's because it's actually sweeping through the waveform, and of course it's not always at a zero crossing. So you get a click when that happens. So really what we want to do is to envelope each grain, or in this case the grain. We haven't got several grains yet, we will do, that'll be the next thing. And to do that I'm going to use a trapezoid object. And what the trapezoid object does is basically to create a trapezium or an envelope. Perhaps if I use a breakpoint function editor to demonstrate this. So imagine that this covers, although it's going to say something different at the top of that display. Imagine that this side of the function object represents the number 0, and this point represents 1. So we've got what is essentially phase information. If you remember, when we talked about a waveform or a repeating waveform, the cycle object for example, the phase information of that goes between 0 and 1. So that's what we're talking about here. So we're talking about this walking through that space as being phase information between 0 and 1. The trapezoid object has 3 inlets. One reads phase information, so it reads a value between 0 and 1, which is going to be sent via signal, or in signal. So that is why we've got the line object outputting 0 to 1 up here. That's why we converted it to 0 to 1 in the first place. It's because of this enveloping functionality which trapezoid offers. The second and third inlets are representing the points at which we reach a value of 1. We reach a value of 1, and when we start ramping down from a value of 1. So that, again, this is why I'm using this function object. So if we look at this as being a value from, or in phase information from 0 to 1, the first inlet represents where the ramp up finishes, so where we reach our optimum amplitude, which is a value of 1. And the second inlet determines when we reach the end of that period, so when we start to ramp down. So when we finish ramping up, when we start ramping down, is what these two inlets represent, and they do so on the basis of a value between 0 and 1. So if you put 0.1 into the left hand inlet, we will get a ramp upwards, which is of about 10% of the envelope, and if we put a 0.9, then it will start ramping down at 90% through that envelope. So it creates a shape that gives you a well, basically prevents it from clipping. Now, of course, you could that also means that you can have quite an abrupt, relatively abrupt attack and an abrupt decay, or you could have a much slower attack and slow decay, or you could have an abrupt attack and a slow decay, and so on. So you can you have some degree of control over the enveloping. There are other means that you could use to get more control over the enveloping, but this seems to work quite well. So we will connect this to the line object like that. So remember that this is outputting 0 to 1, so this is reading through what is essentially this table, although again I'm only using this just to show you what's going on. So we'll use 2 float point number boxes and send the output of that into, we're going to use it to control the volume, so as usual we will use multiplication object to do that, signal multiplication object for the 2 outlets here. And send those out to output for the time being. So now hopefully if we send a value of 0.1 here, and a value of 0.9 here, we should get a ramping of our waveform that, or sorry, of our grain that looks a bit like that, which you can't really hear particularly well. But notice that now that I'm dragging through this, we're not getting any sound at all, because the end of the trapezoid shape brings us back to 0, which means that we're getting 0 value as I'm in terms of amplitude, so we're not going to get any. But you can hear the ramp there, certainly. And obviously, the longer your grain length, the longer, relatively speaking, are going to be your attack and decay times. That may be something that is not ideal for you, in which case you might be looking for other solutions for doing your enveloping, but in this particular instance it doesn't really matter too much to me, so I can make that a little bit more abrupt. And of course what you could do is have some kind of mapping that on the basis of your grain length will change the shape of your trapezoid in order to give you appropriate values for maintaining a relatively fast or relatively slow attack or decay. And of course, if I reduce the grain length, we get a clean grain ultimately. So enveloping is quite a useful thing to be able to do.